I'm Anil Kumar, and here is a test question for you. In previous videos, we have learned how to find equation of the asymptotes and behavior of the function near the asymptotes. Now, this particular question is for you to practice. The question is, determine the equation of the asymptotes and explain the behavior of the graph of the function near the asymptotes. You can pause the video and answer the question, and then look into my suggestion. So we have two different graphs here. Let me name them as A and B. In the first graph, we have two kinds of asymptotes. One is the horizontal asymptote, right? So this is your horizontal asymptote. So we can write horizontal asymptote as the value is 1. So it is y equals to 1. And then we have two vertical asymptotes. So let me use a different thing. So we have two vertical asymptotes. So these are the two vertical asymptotes. Function is approaching negative or positive infinity as x value approaches plus or minus 1. So we have two vertical asymptotes, and the equation of these vertical asymptotes is x equals to minus 1 or x equals to plus 1. Right? So that is how we could get equation of the asymptotes. Now the second part is behavior near the asymptotes. So what we can see here is that for the horizontal asymptotes, in both the cases, left or right, that means as the function approaches negative infinity, so as x approaches negative infinity, the function approaches horizontal asymptote from above, right? So this is from above, and there also as function approaches positive infinity, function will approach horizontal asymptote from above. The idea is the function will never be at that value, but it approaches. In both the cases, it approaches from above. As far as the vertical asymptotes are concerned, if we analyze at negative 1, x equals to negative 1, what we see here is that the limit of the function as x approaches negative 1 from the left side, right? Negative 1 from the left side is positive infinity, right? Is positive infinity. However, when this function approaches from the right side of minus 1, so that is to say limit of the function when x approaches minus 1 from the right side, in that case the limit is negative infinity, right? So this is negative infinity. So that is how you analyze behavior of the function near the asymptotes. Similarly, you can write down behavior near x equals to 1 also. So you can say limit of the function when x approaches 1 from positive side is positive infinity. And you can say limit of the function as x approaches 1 from negative side, there it is, right, from the negative side is minus infinity. So when you sketch the graph, you know the graph will look like as shown here. So that is the behavior near the asymptote, correct? So that is how you're going to analyze the first graph. Now let's understand the second graph. Here what we have is that the function is approaching a line, right? So the function f of x approaches line. Equation of the line is going through center, origin that is. So it is y equals to b value is 0 and the slope is 1. So y equals to x. So the equation of this line is y equals to x. You will observe that it is above the asymptote, of course oblique asymptote, right? As x approaches positive infinity, right? So at this side it is above, right? On this side it is below, right? And you say it is below the oblique asymptote as x approaches negative infinity. So that is the behavior near the asymptote. You get the point, right? So it has only one asymptote, that's the oblique asymptote, and behavior near the asymptote is, or end behavior you could say, when the function approaches positive infinity, it is approaching the line y equals to x from above side, And when it approaches negative infinity, it approaches line from below. So that is how you need to explain behavior of the function as x approaches positive and negative infinity, or end behavior. Correct? I hope that is clear. Thank you.